All right, welcome back. Just really quickly going to have this on the screen and then get right back to review material. So remember, if you're in my Tuesday, Thursday class, our last day is Thursday, May 7th. Final exams are due by midnight, May 7th. Remember, we're doing those in Connect. And then my Monday, Wednesday class, finals are due by 11:59 p.m. May 11th. Your last day is Monday, May 11th. And remember, we're not holding class on those last days because you'll be testing. You might need the test time. Sorry, you might need the class time to take the test, depending on how the rest of your life is. If you are ready for the final before then you can take the final before then. There is nothing wrong with that. You got to get 80s on homeworks and quizzes, 75s on the regular tests, 70 on the final to pass. If you don't pass the final, you don't pass the class. You only get 2 attempts. I cannot give extra attempts. You are allowed a calculator. You can print your formula sheet ahead of time in Connect and Resources, and then whatever that other tab was I showed you last time. These were the types of failing grades you could receive. Remember, the whole grade change policy does not apply to this class because we never had a GPA associated with it, and that was the whole reasoning why TCC was doing grade change. So just because your credit level classes are giving you the options for A's, B's, and C's, we don't have that. That was never an option to begin with, so that's not going to be possible. All right, so Chapter 2, dealing with decimals. Hold on 1 second. So Chapter 2, decimals. We dealt with converting them. Between decimals and fractions, that is. And we said that there was a couple different scenarios if you're going from fraction to decimal. If you're going fraction to decimal, you have 2 scenarios. If the bottom is a power of 10, so 10, 100, 1,000, etc., then you need as many decimal places as the number of zeros in the bottom. If not, you must do the long division. Long division, you go until you don't have a remainder unless they tell you to round. If they tell you to round, you always have to go 1 more place. So if they tell you to round to the nearest tenth, then you have to show division to the nearest hundredths. If they tell you to round to the nearest millions, then you have to do your division to the nearest 10 millions. 10 millionths, there were thus there. If they were told to round to the nearest millionths, then you go to the 10 millionths because you need 1 more place to look at. Going from decimal to fraction, then the number of decimal places tells you how many zeros go in the bottom. So again, 10, 100, 1,000, etc. So if you had 0.5, then your bottom would be 10. If you had 0.05, the bottom would be 100. If you had 0.005, the bottom would be 1,000. And then the top is just whatever that number was without all the decimals and everything. That's all it is. So let's pull up our work page. So this is chapter 2. Actually, before I do that, I like to make my little memos in here. Example 1. We're going to convert. So if I have 0.04, you'd say there's 2 decimal places. So that tells you that the bottom is 100. 2 decimals, so 2 zeros. And then the top is just this 004, but we don't need the zeros in the front, so just the 4. But of course, with any fractions, you must reduce. 4 goes into 4 once and into 125 times. So I divided each of these by 4. And there's our answer. They don't always reduce. B, let's say we had, I don't know, 3/10. Well, that's a fraction, so we need to convert this to a decimal. Because the bottom is a power of 10, I don't have to do the long division. I still can, you'll still get the same answer, but you have a shortcut. 1 0 means 1 decimal place. So that means 1 0 says that there should be 1 decimal place. So it should go 0.3. You write the 3 and then give it 1 decimal. C, let's say we had 21/50. So here we've got a fraction where the bottom is not just a power of 10. Yes, it ends in a 0, but that's not a power of 10 because it starts with a 5. Powers of 10 are 10, 100, 1,000, things like that. So you have to do the long division. You got to put the 50 on the left and the 21 on the right. Let me just do that over here for the sake of space. 50 cannot go into 2, so you don't put anything over it. 50 cannot go into 21, so you do not put anything over it, and by it I mean the 1 now. But that doesn't mean you just stop, so now we have to put a decimal, put a 0, put a decimal above, and continue on. And we say 50 into 210. We kind of ignore this decimal for the division part. 50 into 210 would be 4 times. And you put the 4 over the last digit you divided into. Then 4 times 50 would be 200. Subtracting 210 and 200 will give us 10. But that's not a remainder of 0, so we need another 0, and we bring it down. 50 into 100, that's 2 times. 2 times 50 is 100. Subtracting, you get 0. Remember, even though you're allowed calculators for this test, you should still be capable of doing things like this. That skill should never go away. It should never rust. So 21/50 would be 0.42, and that would be our answer. Let's do one more, D. And let's go with 3/7, and we're gonna say round to the nearest hundredth. Round to the nearest hundredth. So the bottom's not a power of 10, so I have to do the long division. And again, I'm gonna just kind of to give myself some space. We'll put the 7 on the left, the 3 on the right. 7 can't go into 3, so we definitely need a decimal and at least 1 0, but I can go ahead and put the number of zeros I know I need. We were told to round to the nearest hundredth, which means we need to divide to the thousandths place. So I know I need this many zeros. Why not go ahead and set the problem up like that? You don't have to, but it's helpful. That way you don't do more than you have to or less than you have to. So 7 went into 3 0 times. I'll go ahead and put the 0 there this time. 7 will go into 34 times. 4 times 7 is 28. Subtracting, you get 2. Bring down the 0. 7 will go into 20 twice. 2 times 7 is 14. Subtracting, you get 6. Bring down the 0. 7 will go into 68 times. 8 times 7 is 56. Subtracting, you get 4. That's a remainder because, well, we're supposed to stop here. We're supposed to round, but the remainder doesn't matter, so it's not like I need to note it. So then we look at the 8. That 8 tells us to round up. So the 0.42 becomes a 0.43. Very close to the last answer. So that was an approximation. That was rounding. Rounding is good. We also covered writing words as decimals, writing decimals as words. I'm not going to do any review problems with that. There's nothing too crazy. Like I said, I can't cover every single little detail, and I will have to actually cut today's lecture a little short, but not too much. Okay. So rounding, we just did a problem involving that, but just to be safe, I'll put it up here. You need one more place. Actually, I don't want to say it that way. That's just when you're setting up the long division. It's always true, but let me just say it a little different of a way, more similar to how we introduced in class. You have to look one digit to the right of where you're told to round. A number 5 or higher, you round up. A number 4 or lower, including 0, you round down. Now remember, rounding up means the digit where you're told to round to increments by 1, meaning it adds 1. If you round down, it stays the same value and you just cut everything else. Oh no, my power just flickered. It's really windy outside, and the last time we had windstorm, I lost power. So it's not storming yet. It's just windy, but I'm sorry. I'm a little scared for my technology right now. I'm hoping this doesn't just go to the abyss because I know nobody's watching live. Even though you should be. Some of you at least. I know my other class I can't do it live. But my Tuesday, Thursday I am. All right, let me get my distractions out of the way, and let's go to adding and subtracting. Decimals. Line up the decimal place. That's pretty much it. Line up the decimal place, add or subtract as necessary. Multiplying and dividing decimals. I'm going to put this all on one page. Actually, not multiplying and dividing, just multiplying decimals. I am extremely distracted right now. I'm just watching my light flicker. You do a right alignment. Dividing decimals. You have to make sure that you are not dividing by a decimal. So that means the bottom can't be a decimal. You move its decimal right until it's whole, and then you move the top decimal the same number of times. Also, one more memo for multiplying decimals. With the right alignment, then you do the multiplication like there's no decimal there to begin with, but then you add up the number of decimal places in the original values, original numbers, to get how many you need in the answer. So again, nothing new. And then we're going to go to example 2. Let's do 5.93 plus 12.076. 5.93 plus 12.076. So I have suggested to line these up vertically. Don't just use your calculator for this, for the love of math. Do the work. Do the work. Do the work. It's okay to use a calculator for something like this in part of a bigger problem. If this is the problem, I didn't ask the calculator to do everything. I asked you to do it, so please do the work. All right, so 5.93, and then we need to line up the decimal because this is an addition or a subtraction, and then we have our 12 as the whole and the 076. I'm going to add this extra 0 above the 6. It's not necessary all the time, but it's very helpful most of the time. And then we just add vertically. 0 plus 6 is 6. 3 plus 7 is 10. Carry the 1. 1 plus 9 plus 0 is 10. Carry the 1. Bring down your decimal. 5 plus 2 is 6. 6 plus 2 is 8. Just bring down the 1, and we get 18.006. Let's swap the numbers and subtract them. 12.076 minus 5.93. So 12.076, 5.93. Make sure you're lining up the decimal. Really a good idea to have this 0 in my opinion, but again, some people will argue you don't need to see it. 6 minus 0 is 6. 7 minus 3 is 4. We can't do 0 minus 9, so we borrow from the 2, so that's now a 1. This 0 is now a 10. 10 minus 9 is 1. Bring the decimal. And then 11 minus 5 is going to be 6. I'm not going to show the borrowing for the very last digit, especially when it goes to 0. So 6.146 is our answer. That is a 6 at the end. 6.146. C, and I'm not just going to take those and multiply them. That would be a much bigger problem than the last two. Let's do 2.09 times 1.6. 2.09 times 1.6. So we're going to stack these vertically, but I'm not going to line up the decimal this time. I'm not going to write it as 2.09 times 1.6. I'm not writing it that way. I'm not lining up the decimal. I will write it as 2.09 times 1.6. That's the right alignment. Then the 9 times the 6, I'll show my work in red for the first row. 9 times 6 is 54. Carry the 5. 0 times 6 is 0, plus the 5 is 5. 2 times 6 is 12. We're done with the 6. So now we got to use the 1. Because this 1 is in the second place in terms of all our multiplication, ignoring the decimals, we need to make sure we start there so we zero out the first. 9 times 1 is 9. 0 times 1 is 0. 2 times 1 is 2. And then we just add everything up. That from the right to left would be 4. 5 plus 9 is 14. Carry the 1. 1 plus 2 plus 0 is 3. 1 plus 2 is 3. Then for the decimals, we have 2 decimals in the top number, 1 decimal in the bottom number, meaning there should be 3 in the answer. So it's 3.344. All right, for D, let's do 3.344 divided by 1.6. Another way to write this would be 3.344 on top of 1.6. There's about the same thing, and we mentioned previously that you can't divide by a decimal. So each of these decimal places needs to move right however many times until the bottom is whole. So this one has to move right once, and this one has to move right once. So that gives us 33.44 divided by 16. That's the division that we actually need to see. So we'll put 16 on the left, 33.44 on the right. Now you might be wondering why I use these two particular numbers when you kind of saw them over here. Well, let's see what happens. 16 will go into 33 twice. Make sure you bring your decimal up. 2 times 16 is 32. Subtract and you get 1. Bring the 4 down. Now 16 can't go into 14, so that's 0. 0. Now some people just say, oh, we'll just go ahead and bring the next digit down. I mean, hey, that works, but I'll show the full steps. 0 times 16 is 0. Subtract and you get 14. Bring down the 4. Now, the people that say just bring down the next 4, they still have to write that 0 there. And that's why I like to show the extra work, because people tend to rush and then they'll miss the 0. And 16 is going to go into 144. If you show your multiplications to the side instead of just relying on a calculator, eventually you'll come up with 9. sorry, excuse me, I had to cough. And then 9 times 16 is 144. Subtract and you get 0. This is an interesting answer. You get 2.09. 2.09 times 1.6 was 3.344. 3.344 divided by 1.6 is 2.09. Also, if you did 3.344 divided by 2.09, you'd get 1.6. There's a strong relationship between multiplying and dividing numbers. All right. All right. We saw the stuff for circles in this chapter. I'm going to leave that for the chapter 3 material because honestly it's all the same and it's in the same section of your formula sheet. The one thing that I'll remind us is that pi is approximately 3.14 if you round to the nearest hundredth place for it. You can also say that pi is approximately 22/7. Now, our book really never used this, but there are other books, there are other teachers that would use this approximation, especially when you're dealing with three-dimensional geometry. Because a lot of those formulas had fractions built into them, it can actually make sense to use a fractional representation of pi so you're not mixing fractions and decimals. We really don't like mixing fractions and decimals. It's not the best idea in the world. Not saying you can't always, it's just not a great idea. It complicates things. And there goes the trash blowing in the wind. Like I said, I'm easily distracted. Percents. So remember that it's really weird. It doesn't like the plural of percents. I mean, the plural of percent is percents as a word. Percentages, percents, either way. So percents. This is a ratio per 100. The word percent literally means per 100. So it's a ratio per 100. So 73% means that you have 73 out of 100 things. 2% means you have 2 out of 100 things. Oh, and I have to sneeze. I don't want to sneeze in your ear. And I didn't even sneeze, it went away. So we can convert between percents, decimals, and fractions. We said to go from a percent to a decimal, you just move the decimal twice to the left. To go from a decimal to a percent, you move the decimal twice to the right. Now, of course, you insert or delete the percentage sign as necessary. We already described how to go between decimals and fractions previously, so I'm not going to write the same thing twice in a review. And then we said to go between percents and fractions, or fractions and percents, either way. You could just use the decimal as a middleman, which was my big suggestion because a lot of people mess this up. But if you're going from percents to fractions, so let's say you had 50%, that ends up being 50 over 100. So you just put, or you can say multiply by 1 over 100. If you're going from fraction to percent, you multiply by 100%. So again, these last two, a lot of people don't like just going directly between percents and fractions. They like to use decimals as a middleman, and there's nothing wrong with that. In fact, I would say I more often than not do the middleman. I don't know what it is, but I don't always like a middleman, but I do for going from percents to fractions or fractions to percents. And always do it. If it's a nice, pretty number that I can do off the top of my head, then I will. All right, so example 3. Fine. Let's say convert to the other two formats. There we go. So for A, let's start with 34%. So if you move its decimal twice to the left to get the decimal, that would be 0.34. And remember, I gave you a nice self-check that the value should look bigger as a percent versus a decimal. The value should also look bigger as a percent versus a fraction. And then if you want to convert this 0.34 to a fraction, well, there's two decimal places. So that says 100 is the denominator and 34 is the numerator. This reduces though, 2 goes into 34 17 times, 2 goes into 150 times. So 0.34 and 17/50ths are our answer. Let's go with, I don't know, 3/5. Let's convert this to the other two formats. So I'd say the easiest thing to convert this to next would be the decimal. And if you do that work, let me just kind of squeeze that up here. You put the 5 on the left, the 3 on the right. You're probably going to need a decimal because 5 does not go into 3. So there's a 0. 5 will go into 36 times. 6 times 5 is 30. And you get a perfect remainder of 0 already. So 3/5 is 0.6. Then if you move its decimal twice to the right, you would get 60%. There was no reduction needed this time because we didn't have to get a fraction. So we started with a percent, we started with a fraction. Let's start with a decimal. Let's go with 0. Actually, I don't want to do 0. Let's do 2.95. So I think it's easiest to switch this to a percent first. So you move the decimal right twice and you get 295%. Now to go to a fraction, I'm actually going to use the percent. So to get the fraction, I'm going to start with the 2.95 again. So again, to get the fraction, I'm looking at this because I see two digits, two decimal values. I said digits, two decimal places. That says my denominator would be 100. So this has a denominator of 100. And then you can just write the 295 in the top. Now this is an improper fraction. If you wanted to write it as a mixed number, the 2 would be the whole and the 95 would be the top. And this definitely reduces. 5 goes into both of these quite a bit, right? What's that? 59. 295 divided by 5 is 59. And then 100 divided by 5 is 20. Nothing else goes into both of those, so that's your answer. Then we had our percent problems. We had our word associations. We had the word of, means times. We had the word is, or lots of variations to that. We said that means equals, an equal sign. Then we had the words what or what number or what value. Those all mean X. And then I said that I really suggest if you see the phrase what percent to instead use the letter P because there was an extra step at the end. You typically had to convert a decimal to percent at the end of the problem. Let me just delete a space or two. So there we go. This is when we had to introduce the very basic concept of algebra, solving equations, where like if we had a 3x equals 12, we had to divide both sides by 3. We officially really heavy-handed covered that in chapter 3, but we did still introduce the concept in chapter 2. So what do we have? 2 example, what do we say, 4? 4. All right, and let's say, $25% of what is 380? 25% of what is 380? So the 25%, first of all, you have to convert that. 25% is 0.25. You can't have percentages in equations. You have to convert them to decimals or fractions. So the 25%, we write 0.25. The of, we write a times. The what, we write our variable x in whatever letter we like. Is, we write equals. 380, we write 380. Then we have to divide both sides by the number paired with the x, because that's times. So we divide both sides by 0.25. And this was the section where we started to be allowed to use calculators. So I'm just going to do that really quickly in the interest of time. And you'll get 1520. So that little double arrow is just me saying, hey, look over here now. So you get x equals 1520. Let's call that A. We'll do one more. And we'll say, what percent of 90 is 9? What percent of 90 is 9? So what percent? We're supposed to write a P. Of means we write a times. 90, we write 90. Is, we write equals. 9, we write 9. Most people are going to flip the order of this, so they'll write 90 times P is equal to 9. That's 90 times P equals 9. So we divide both sides by our 90. And 9 divided by 90, if you reduce that as a fraction, it's 1/10, or 0.1. If you show it with a calculator, it's 0.1. Either way, you're going to get P equals 0.1. This is not the answer. That is not a percent. You must convert that by moving its decimal right twice, which gives us 10%. We had simple interest. I equals PRT, principal rate times time. Interest is the product of principal, annual interest rate, and time. This is simple interest. I'm not going to do an example of that because it's literally just plugging in 3 numbers and multiplying them, and you're allowed calculators. Everybody aces this. Everybody should ace it at least. Then we had conversions, which was the biggest chunk of chapter 2 at the end. So we said in the US system, we multiply by a fraction with the old units in the bottom and the new units in the top, so that we would out with the old, in with the new. This is called dimensional analysis. It is a very important field of mathematics. You can do some crazy things with such a simple idea. In the metric system, we had that line with metric units on it, which is in your formula sheet. All your conversion formulas are in your formula sheet. The metric line is on your formula sheet. So you had like your kilometers, then your hectometers, then your decameters, then your meters, etc. It looked like that. So you start on the initial units, move to the new units, and then do the same thing to your decimal in terms of left or right and number of times. When we were going from US to metric, or metric to US, it could be a combination of both of these things. You usually saw the dimensional analysis type, but sometimes you need the metric line too. So for example, on our formula sheet, we know that, hold on, I gotta pull up one. Well, I know one off the top of my head. 1 inch is 2.54 centimeters. But what if I wanted you to go from inches to meters? So you'd have to use the fraction multiplier to go from inches to centimeters, and then you would use the metric line to move the decimal place to get to meters, which would end up being twice to the left. Maybe I'll use that as an example. Not immediately though. Example 5. So some more pages? Yes, I do. Okay. So just a few of these. So for A, let's go with 5 feet, and we want to convert this to inches. So you'd go to your formula sheet and you would find that 12 inches is equal to 1 foot. So you're either multiplying you start with the original, you start with your 5 feet, and you're going to multiply by either 12 inches over a foot or 1 foot over 12 inches. And you want to have out with the old. So when I show my multiplication, I'm going to look at this. I see this is my feet. That's my old unit. I want that gone. So that tells me feet have to go on the bottom. So because feet are here, feet need to be here because our original units are in the top, they have to be in the bottom. Now, if you're dealing with a conversion of rates, if you have units in a bottom originally, they actually have to go in the top in the multiplier so that you get the same cancellation. But we don't see that in our class. You'll see that in QR though. All right, and then everything else is just this 12 inches is equal to 1 foot. So we know it's 1 foot to 12 inches. So the feet cancel as we want. And then we just multiply or divide 5 times 12. If the 12 had been in the bottom, we would divide. 5 times 12 is 60. The units that we see left over are inches. So you can do this for converting links or converting capacity or converting weight or converting time. We had 4 different categories of conversions for this. It doesn't matter what the units are as long as you have a formula to convert from one thing to another. Sometimes we had to do this through multiple steps, multiple fractions. So let's say I wanted to go from, oh no, there goes my, okay. Math notes, math review notes. Examples with work, which one's it gonna be? Probably the auto recovered. Okay, and then with work. Well, that's gonna be annoying up there for now. Whatever, God, I hate technology. All right, so B, there's the B. What was I doing? I got frazzled. Capacity, that's right. So let's say we wanted to convert 2 gallons to cups. Well, if you look in your table, there's no direct conversion from gallons to cups, even though you can make up your own. We see that 1 gallon is equal to 4 quarts. And then in that list, we also see that 1 quart, we see one that says it's equal to 2 pints and one that says it's equal to 4 cups. Since we're going to cups, let's use the cups then. So 1 quart is 4 cups. So we start out with our 2 gallons. We're going to multiply by a fraction. We got to get rid of the gallons, so I know gallons go in the bottom. We can convert between gallons and quarts, and it's 1 gallon is 4 quarts. So our gallons are gone. That'll put us in quarts. But we're supposed to go to cups. So we do another one of these multipliers, and it could take 3 or 4 or 5 of these depending on the problem. We know 1 quart is 4 cups. We're starting with quarts. We want them gone, so quarts go in the bottom. There's the 1, so this is the 4 cups. Quarts are gone, and then we're just multiplying the 2 times 4 and the 4. 2 times 4 is 8, 8 times 4 is 32. So 2 gallons is 32 cups. So if you have 2 gallons of juice and you have maybe say 15, 20 people at your party, you know you can make 32 cups. As long as everyone's not going to have more than 2 cups, you should be fine, right? That's what you can do with that. C, let's go from 5 kilometers to, what do I want to do? Let's get weird with it. Decimeters, lowercase d. So as a reminder, we have our meters in the center. The far left is kilometers. To the right of that is our hectometers. To the right of that is our decameters, and that's a DAM. Then our meters. Then to the right of that is our decimeters. To the right of that is our centimeters, centimeters, and then our millimeters. You don't have to memorize that. It's in your formula sheet. So we're starting with kilometers, which is right here. We got to go to the decimeters. 1, 2, not that one, 3, 4 to the right. So that's the same thing you do with your decimal, which is originally here. 1, 2, 3, 4 to the right. There's 4 blank spaces, so we put zeros in there, meaning that our answer is 50,000 decimeters. Uno más. This was going to be my inches to meters. So let's go with, I don't know, 7 inches to meters. Well, when you go to your formula sheet in the metric to US conversion section, you'll see that 1 inch is approximately 2.54 centimeters. But we need to go to meters, so after you get to centimeters, then you can use the metric line, the same one as above. So we start with our 7 inches. Sometimes you have to do the metric line, then the multiplier. It depends on the problem. So we're going to multiply by, out with the old, in with the new. We started with inches, so inches go on the bottom, centimeters go on the top. How many did how many? 1 inch is 2.54 centimeters. All right, definitely going to use a calculator for this in the interest of time, but you're allowed. 7 times 2.54, you get 17.78 centimeters. Then we can have our line, km, 2, 3, 4, 5, 6, 7, hm, dam, m, little dm, cm, mm. So we're starting in centimeters, which is over here. We're converting to meters, which is 2 to the left. So that's what we do to this decimal place. We're going to move it twice to the left. So 17.78, 1, 2 to the left. So this would be 0.1778 meters. All right, finally, temperature. We had 2, arguably 4. Formulas. If given C, use the one that says F equals, and vice versa. It doesn't matter if you use the one that has fractions. It doesn't matter if you use the one that has decimals. Nobody's going to care. You just have to use the appropriate formula. Otherwise, you're going to be stuck doing some algebra that you don't really want to have to do. Trust me on that. It's a little above our pay grade. So we're just going to do one of these. Example 6. Oops, black. Convert Let's go with 40 degrees for A, 40 degrees Celsius. So if you go to your formula sheet, you'll find the formulas. And for this one, we would want to use the one that says F equals. And I like the one with fractions personally. So 9 over 5 C plus 32. So we go F equals 9 over 5 times 40, because that's our temperature in Celsius, then plus 32. 5 will go into 48 times. So that's 9 times 8 plus 32. Watch your order of operations. 9 times 8 is 72 plus 32, and that's 104 degrees Fahrenheit. And that was A. I know I wrote the A a little small. B. What do I want to do? $59 degrees Fahrenheit. 59? Yeah. So a cool day, not a cold day, not a hot day. Some people will be really comfortable here. Some people got jackets on, just depends on. So because we're converting Fahrenheit, we need to use one that says C equals. And again, I typically like the fraction ones. So I'm going to go the 5 over 9, parentheses, and then F minus 32. That's the formula we use that you don't have to memorize. So C equals 5 over 9, parentheses, 59 minus 32. 59 minus 32 is 27. 9 and 27 will reduce to 3, so that's 5 times 3, which is 15 degrees Celsius. Temperatures sound a lot colder when you say them in Celsius, especially because we're used to Fahrenheit as Americans. If you're not an American, if you're used to Celsius, then pardon my assumption. Is there anything wrong with Fahrenheit? No, it's just most people in the world would argue Celsius is better because it's based on factors of 10, just like the entire metric system. The US system is very old, it's very archaic. It has a couple other names as well you may have heard of that kind of rely on that archaic notion. But Celsius was always built around 0 degrees is when water freezes, 100 degrees is when water boils. So when we say that it's 70 degrees outside and comfortable, if we had said that, if we were used to the Celsius system, we would not say it's 70 degrees and comfortable outside. Our skin would be melting practically because it would be very, very hot if it's 70 degrees Celsius. So when you talk temperature, don't just say it's 70 degrees, say it's 70 degrees Fahrenheit. That way, in case you're talking to someone who doesn't use your same number system, you're not misconstruing anything. So that is it for the chapter 2 review. I'm going to save the chapter 3 review for next time, especially since we just covered chapter 3 fairly extensively for the past several weeks. And then, yeah, like I said, that'll be our last video together. So please, I know if I say please watch this video, if you don't watch the video, you're never going to hear it. It's kind of an irony there. But so those of you who are watching the videos, please keep up with your work. Please email me. There was a tech issue that actually 2 people pointed out to me yesterday, that some of you were not allowed to progress through your homework anymore. That's because you were very, 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 very far behind on your homework. And this course was originally set up so that you didn't really have infinitely much time. Eventually, we were supposed to shut you out, but with how things are, we're just giving everybody a shot. If someone can pull through at the very last second, then it is what it is. It's not my favorite thing. You probably aren't going to learn you're not going to take away as much from this course as someone who's actually studied all semester and practiced consistently. Cramming does not make things stick with you. It makes you do okay on a test and then you forget everything tomorrow. So please understand that moving forward. Please be responsible, students. It's going to help you in your lives, etc., etc. Besides that, have a good one. We'll see you next time on the internet. Email me with questions and have a good day.